Hello, today's topic is Limnic Eruptions. So what is a limnic eruption? Well, it's an eruption that's limnic. According to the Collins Dictionary, limnic is relating to bodies of water with low salt concentration, such as lakes and ponds. An eruption is a bursting forth or out as of lava from a volcano. So, a lake volcano? Okay, so we now know what their definition of the phrase is, but what is exactly? So first, we have to look at the cause of this. So there's a volcano and it explodes, which is the result of some really hot rocks below underground being too hot to handle and being pushed up, and then expelled everywhere. This involves the geosphere and the atmosphere, since the hot rocks exploding everywhere causes smoke and ash and other stuff. But then afterwards, there isn't as much hot rock or lava being pushed upwards, so the volcano goes dormant. Then a weed dip forms, and then rain from the hydrosphere and atmosphere makes a nice lake. Except it's not a nice little lake, it's actually a bomb waiting to go off. Even though the magma isn't being pushed upwards, it's still leaking CO2 everywhere. Well, actually not everywhere, just beneath the lake, which is actually really bad because it causes a chemical reaction. Because CO2 is soluble, that means the CO2 will dissolve when it touches the water, which means there's a super compressed pocket of CO2 and other gases underneath our little lake. This is great, wonderful, awesome, except whenever it becomes disturbed. For example, an earthquake, which is the result of friction underground from moving tectonic plates, which is part of the geosphere, as tectonic plates are just really, really big, flat rocks. It messes up the lake and causes an opening. The pressure from underneath the water explodes, and the gas is released from the chamber, which is relating to the atmosphere, since CO2 is a gas. Wait. But isn't CO2 heavier than water? How does the opening in the water allow it to escape if it's heavier than water and also heavier than oxygen? And is CO2 hydrophilic or hydrophobic? Because if it's hydrophobic, then it can't mix with the water, but it's soluble? How does that make it carbonic acid if it can't mix with the water? Well, I don't know why it does that. We have some help with some scientists who can help explain.
Magma releases huge volumes of carbon dioxide, which can filter up through the crust of the Earth into the bottoms of the lakes. Now, these lake bottoms are highly pressurized and very cold, which is exactly what gases need in order to dissolve in water. So, lots of carbon dioxide can dissolve in the lakes and just build up, sitting there. But as the CO2 continues to build, those lakes get to be like cans of soda pumped up with way too much fizz. Most lakes don't explode, thankfully, even if they're sitting on top of a whole lot of magma. That's because the water gets mixed around when the temperature changes throughout the year. In the fall and spring, the changing surface temperature affects the water's density and keeps it circulating, and in turn helps release the gas. But in Lake Nyos and Lake Manoon, things are very different. It's hot pretty much all the time, so the shallower, less dense water stays at the top of the lake, where the gas-infused deeper layers stay below. As a result, tens of millions of cubic meters of carbon dioxide can accumulate.
Wow. Anyway, the gas escapes and it floats down and kills a bunch of things because it suffocates everything. This is the work of the atmosphere and the biosphere, as the air helps push it down and the biosphere is directly impacted in the event. Therefore, people living below where the eruption took place and any animals in the area are killed. This also impacts the anthrosphere, as people are no longer living there, and it causes people like you and me who are trying to figure out how it works and how to prevent it from happening in the future. Solutions to this include pumps that remove the CO2. Okay, bye.